to use this video to show you how to graph a function in Desmos and have it make a table of values for you that you can either use to check your work or to graph a function. So I'm going to start with the linear function. I'll just do y equals 3x plus 4. So we see the line is graphed for us. That's nice. We can use Desmos to find the y-intercept and the x-intercept. But sometimes you're asked to make a table of values and then see if those points match the line. So while this is selected, choose the Edit List and change this to a table. Once you have it in table form, Desmos has given us some x values and then plugged them into the function 3x plus 4. So it took 3 times -2 and got -6, and then added 4 and got -2. So it has calculated the y values for you given the function that we entered. You can change these values. So let's say I wanted to know what when x was -4, and it'll automatically recalculate. And it also shows you the points on the line. So this is a really handy tool that Desmos can help you with. Let's look at a quadratic function. Y equals, I'm going to do x squared. Whoops. I'm not sure where my x is capitalized. I'm going to change that. There, y equals x squared. Change it a little bit. 4x plus 13. Now, Desmos has a keyboard, so if you don't remember how to get the squared term, you can use this to square it, and it also has other values. I'm going to turn off the linear function by just clicking on the colored dot and resize this a little bit so I can see what's going on. So it's way up here. So I'm going to change the scale so that I can recenter this a little bit. I don't need to change much. I'm just going to change the y-axis so it shows more numbers higher up. Let's go to like 30. So now when I look at my graph, I can see more of my function. What it did is it reduced the scale of the y-axis while leaving the x-axis, which is nice. Now I want to look at a table of this. So again, I have this selected, which I wanted. I'm going to choose the Edit List button and change this to a table. And now it has used different x values and calculated the y values for me and then placed them on the quadratic function. Now this is great because it shows me the vertex where the turning point is, but I would like to see some values over here. So I'm going to change this. I'm going to use some particular values that maybe I was asked to find for the problem. I want to find the values when x equals 4. When x equals 0 is already here, but I'm just going to put it in again so I have my order the same. -2. -4. This way they'll all be in the order that this question had asked me to find. So if I had done this problem by hand and maybe had made some mistakes when I plugged the negative value in, maybe I forgot that when I square a negative number, it'll always be positive. Now I have like a backup that I can use to check my results. And now I can see that these are symmetric. I have this point here, which you can see is -413, and if I had drawn in this axis of symmetry, then I would see that this one would be on the other side of my axis of symmetry. So you can tell more things about this when you look at the points that are on that parabola, on that quadratic function. I'm just scrolling out now so that I can see a little bit more of what's going on. -8, where is -8? Well, it's way up there. So when x is -8, it's already at 45, and when x is at 4, it's at 45. So I should have changed my scale to even more than 30, but that's okay. I can zoom out just a little bit so I can see it. So this is now a nice, if you needed to get a picture of this quadratic function for your homework, now you can click on the Share Graph button, and you can copy this link. You don't even have to be logged in or anything, and then you can paste that link onto your assignment. Or you can take a nice screenshot of this. If you take a screenshot, it's a nice idea to include this part so that you can see what function it was you graphed. You can also graph, remember, just the function, which was y equals x squared plus 4x plus 13. And if we did it correctly, they should be the exact same graph. So if I turn this off, it's the same one. If I turn this off, you just don't see those points. And then you can proceed from there. All right, thank you very much. Have a wonderful day.